All right, good afternoon, class. Welcome to the first day of CS 477. I guess I hope you've had a good summer and you were safe and everything's been going all right. And hopefully had a chance to check out campus yesterday or this week because it's actually had a lot of people there. So it feels like it's almost like kind of back to normal-ish. So if you have a chance, I would say why not just try to check it out, I guess. Um, so anyway, I guess for today, I'm gonna go ahead and start a screen share. So I'm gonna go over the syllabus, which should be available now on the files tab. I'm not sure why it wasn't available earlier. I actually posted it up on the files section yesterday night, but for some reason it was still locked. But now it should be all good to go. Let's begin a screen share, and then I'm going to go over the syllabus and whatnot. Uh, Move this over here as well. And there we go. So, yep, CS477. I'm Jimmy, so I'll be sort of instructing along the way this semester. My office is located in TBE B308. It's a nice location for an office. It's actually where, if you go to the TBE building, go up the stairs, and after you pass the restrooms, on the left side is where you turn left. That's where my office in the corner section over there. It's got this nice sort of water pipe sticking out of my office, which is does add character to it. I also have other sorts of things in my office as well, where I can sort of, just hang out there sometimes to, do stuff there. So, but I guess I can't really mess with the water pipe because I don't know what type of catastrophe that's going to cause. So that's off limits. Everything else, though, it's all just a nice hangout place. Um, so email is going to be right there as well. So, basically I'll go over the class communication in a little bit. Office hours this semester will be on Fridays from 12 to 2 p.m. So my office hour format will be a hybrid format. As you can see, it says in person or WebEx. It really means hybrid, which means that I'll be there in person, but also I'll sort of have my private WebEx meeting room. I'll start a meeting there, I suppose. You can join in. So I'll have my sort of my earbud microphone set up. But if you want to sort of come in person, that's fine as well. So I'm kind of able to handle both cases. At least I'll try to handle both cases. Um, I thought about having webcams set up as well. So let's say somebody joins in, you can see if I have other students there. If I'm not responding very quickly, it's because I'm talking to other students. But I feel like that might be a very bad idea to have webcam on during office hours. So for that reason, I'll have no webcam on. I'll even unplug the webcam from my computer completely, so there's no webcam at all. Just it'll have my earbuds where I can, talk. So I'll probably have to find some type of way of denoting that I'm helping a student currently in my office right now, so just kind of hang tight and I'll, help you. So I'll find some way to like have something WebEx where I can set up a beacon of some sort where it tells you that I'm helping a student right now. So just, just sit tight on that. I'm not really sure how WebEx actually works. Maybe I'll like look into that maybe this week and see how WebEx actually does all of its stuff, but I could do that. So I'll figure out some method of how that, can be implemented in a good way. So yeah. So anyway, that's that. Now for TA, I was given a TA, I think, earlier today, so I'm going to put his info here on the syllabus, and I'll also let you guys know that I updated the syllabus with the TA's information. Um, so for right now, I guess this also comes up later up in the syllabus. So I want to discuss this right here. So I do have a class Discord set up. Mostly as just a discussion forum. Also, it's a way to contact me. So if you have a quick question on homework or whatnot, Discord's more preferable since I have it on my computer running. I also have it on my phone, so I get automatic alerted when somebody sends me a message on Discord. So it's definitely more preferable for me to use Discord over email. Now, if you have like a more serious inquiry, say you want to have a class, let's say your class grade you want to look at, or maybe you got sick or something, more serious or missing the exam due to some excuse, then I would say use your email for more serious issues. But for a quick question on something, in Discord is definitely more preferable there. But if you use, email for a quick question, that's also fine. I'll respond, but I might not respond as fast because I don't check my email all the time. So I check it every few hours, so I might not be able to respond immediately. Whereas Discord, I'm able to respond. Well, I guess I'm also doing stuff sometimes, so I can't respond right away either. But you have a better chance I'll respond faster to a Discord, a higher probability than, responding faster to an email. So that's kind of that. But I'll go over some more Discord info later on. But let's go ahead and just go into the course description. That's just basically just what's on the course catalog. So you really need CS 302 to be here. I mean, because there'll be some overlap with 302, so I'm trying to make this class not overlap too much with 302. So I was sort of notified about teaching this class around midway in the summer, so I couldn't spend a lot of time preparing, but I prepared a lot of content for this course, so I have to also learn as I go a little bit too ahead of time. But anyway, for most part, I'm trying to have it be maybe like around 50-ish% or so overlap with CS 302, or at least with my 302 class, because there's other 302 instructors who might have covered different content. Maybe they covered stuff that might be in this class. If that's the case, then I guess so be it, I suppose. So anyway, learning outcomes, that's for accreditation purposes, so you don't really need to look at that. Now I have these two books listed here, so I think they're not listed in the bookstore. I wasn't able to set the adoption to the book over there. But anyway, I have these two books, so the MIT and the UC Berkeley book, or I call it UC because there's some writers or some authors in that book who are sort of from UC San Diego. But anyway, the UC book looks like this. I'm not sure if you can see it on camera, but it looks like this, the UC book. So this one actually is much smaller and it's definitely easier to read through. It has it's more of a textbook in a sense. It's definitely easier to understand content in this book. Now the MIT book. This thing is a good door stopper. Maybe even a booster seat for kids. I don't know. This is the algorithms book from MIT. Now, this book is very dense, and pretty much everything covered in this course will be in this book, except that this book is very not so simple to read. It's kind of like reading a bunch of research papers almost in a sense. So it's definitely not an easy book to read, but it covers everything in the class. The UC book won't cover everything, but if let's say there's certain content in the course that's in the UC book, then of course I'd say read that one instead because it's definitely much more simpler to follow. Now, let me see, how do I say this without getting in trouble? Okay, hold on. So you can, do a simple Google search on these books and possibly find a price that's sort of better than in the bookstore possibly. So you can of course look it up online, find a link to this book that might be cheaper than what's listed as new or listed in the course book list or whatnot. That's all I'm going to say about that. You can do a simple Google search and maybe find something there. So that's that essentially. So I have the MIT in blue, UC in red, because in the at the end of the syllabus I have the list of content, list of topics, sorry. And I'm going to link both book chapters there. So it's like you sort of this color coding or it's kind of hash method, I guess. Blue is MIT, red is UC. It's like a kind of like a hash right there. That's a very simple way to map which sections of the book for which for that topic. So that's that. And then class grades. So pretty much this is really almost like a semi type of math class in a way. So all the assignments will be written assignments. It won't be any sort of coding assignments. Possibly on some of the written assignments, there could be write some pseudocode or devise an algorithm given this scenario, write an algorithm that's going to do this. So there might be some kind of code like that, but not actually writing and compiling code, just mostly written assignments will be used. And the assignments will be worth 30% of the grade, and tests are kind of worth a lot more. Because in this class, it's really, it's kind of like your discrete math classes where the exams are kind of, I believe, weighed more than the assignments because it's not like writing code where the coding assignments are kind of the more important parts to it. So definitely written assignments are more important, or not, sorry, exams are more important. So Um, I'm trying to think about the exam format, so I guess I probably won't require webcam. I'm also thinking about maybe not even having the lockdown browser, but maybe just have like a PDF of the exam. You can print it out at the house, work out the exam at your house, and then scan it and send it back on web campus. That's what I'm trying. I'm trying to mostly head towards that path because a pretty small class, I don't have to really worry about having randomized questions like that. And also, I mean, of course you can cheat, yeah, but there's ways, if I have written tests, you can kind of see if there's some answers that are way too similar, you can kind of tell that there was definitely something going on there. So, but I think for a class like this, though, I think having multiple choice questions and true or falses and whatnot is kind of silly. So I'll kind of, during the semester, I'll kind of figure out what's the best solution for this. So anyway, but for now, though, that's going to be the structure. So midterm will be around the 8th week. And the final exam will be on that, final exam week in the 16th week. So 2 exams and then several assignments. So definitely you want to do well in the midterm, I guess, is in the final, I guess. But then again, at the same time, um, this course is the last course you take for your undergrad CS. So there isn't like really a rule for how many students you should pass or not pass. So I don't think the fail rates are very high in 477 or 460 or 456 or anything. So, but anyway, we'll see how that goes. And of course, there's our sort of grade distribution or our percentage to letter assignment, if you will. Um, so once again, I typically, I just want to have the standard grade scale there, so that way you kind of know what it is. Although I think at this point now you would know the standard grade scale. And basically, I always try to do some kind of half letter boost if in case later in the semester I always kind of do that. And there could be sort of a bell curve or a curve type scenario set up if let's say it needs to be done. Usually I do a bell curve or some kind of a curve if let's say the average in the class is pretty low. If it's a high average in the class, then a bell curve is very not useful. So basically, I just try to so for now, we'll keep it like this, but I'll apply a curve if I need to. But typically, I do have a half letter boost I assign at the end of the semester. So that's kind of, the way I sort of, handle that. So let's go ahead and go through the rest of these. So there's our midterm and final dates. So, I'll probably have like if I do have a PDF, you print out the exam, we have the PDF sort of posted maybe a little earlier than 1 p.m. So you have time to sort of, print it out and do it. Although, or you can actually just, have the exam in front of you on a screen, just kind of on paper, write the answers out there, and of course scan and upload those. That's also a possibility. You don't have to print out the exam, I don't think. I don't think you have to do that. But anyway, the exam will be during Thursday at that time, more or less, give or take a few minutes here and there, but that's going to be the overall, exam time. And the final is not set by me, it's the university sets that, so it's going to be on that day from 1 to 3 p.m. So those are the 2 exam dates. And then, of course, the next bullet here is going to be student collaboration, classroom etiquette. So basically, submit your own work. Don't copy, solutions. For algorithms, actually, there are solutions sometimes posted on Stack Overflow or other types of websites like that. So, try to avoid just copying. So, of course, you can look up help online. You can ask, other classmates for, content, but copying, the solution is not a good idea. So, I mean, I will be able to look up the answers online as well. I can see if you copied from that, especially for questions that involve writing out stuff. It's very obvious that it was copied. So, try to just, not just copy do your own work, but of course, it doesn't hurt to look up online, try to get an idea. If in case you're kind of confused on stuff, that's fine, but don't just copy. That's the deal. So, just like for any other class, I'm hoping not to have any issue with this in this course, but if there is, if it's very obvious that, it was copied, then that's when I'm really going to really do anything. If it's like a little similar, but, it's not super terrible, then I'm not going to really do anything. It has to be very obvious that, oh yeah, it was copied. So it has to be something like that. Obviously, just like in other classes, the first time offense is a 0 for the homework. Second time would be a failing grade in the class because you plagiarized too much at that point. Um, Obviously, for exams, it also applies the same rule because Well, if it was in person, I can see you taking the exam, so I know nobody was copying anybody, so I have to really be careful there. But since they're online, I have to also kind of watch out for that as well. So the same rule applies for exams as well. And another thing is Chegg.com. You might have heard about that. I would really just be careful about using that because that's like the worst case scenario. So the CS department has a Chegg account that we can use to log in and check the answer. And if you compare it to someone's answer and it comes out to be very similar, that's a problem. So I'll have to sort of, ask about this because one of my colleagues said that for Chegg, it would be an automatic fail in the class and it would, recommend for expulsion or removal from the program. That's what I was sort of told about that. So it's actually here in the syllabus as well. So just try to just don't use Chegg is sort of the best idea. So that's like the worst thing you can do really. So that's sort of like the main, content there. And of course, for Discord, you keep your, comments clean, emoticons, emojis. I don't know if that's the right words, but I'm getting old now, so emoticons, emojis, and also nicknames. Try to make them sort of appropriate. Don't use any really weird, messed up nicknames, and don't post your solutions up on Discord. Don't make any really weird comments. I don't have issues with Discord too often, but if that happens, I may have to ban you from the server, maybe remove you if you're being way too out of control. But then it never really happens, so I'm not too worried about it. But just FYI, if you do that, then I may have to ban you for that. If you in case do that. So anyway, that's that. So this content right here is really just the policies that were sort of forced. I had to put this onto my syllabus as university guidelines. So misconduct, I guess, plagiarism, all that stuff I already discussed that. You can of course read through that, which you probably won't anyway, but anyway, it's there, so you can't argue that it wasn't there. It was there on the syllabus, so we're good there. Um, I don't know how this happened. Why is it in capital like that? I just literally copied and pasted from. Anyway, not important. So anyway, auditing a course basically it means that you drop in a course, but you can still attend and try to learn what you can learn. So when you retake the course next semester, you have a little bit of a head start. So I guess that's sort of, it's more of an issue you have to deal with. Classroom conduct. Um, I don't know. I don't really have any. I mean, it's online, so I guess as long as you're not disturbing the class, you don't have your microphone turned on and starting to yell and play music in the background. I can mute all of those students, obviously. But if you keep on unmuting yourself, doing all that, then of course you have to like, maybe have to complain to the university that, get this person out of my Canvas course because they're doing this. Although I haven't had issue with that either, so I really can't imagine that being a problem right now this semester. Um, yeah, so I see a question. So the lectures, which I'll say, I guess I should have mentioned this earlier. So I'm going to record them and I'm going to create a YouTube playlist for lectures. And I will actually post, I will actually post the lectures there. And I'm going to post the what's it called, the playlist on Discord. And I'm not going to post a playlist in Web Campus because YouTube and recorded lectures is kind of not sure how university likes that. So I'm going to basically sort of post it, on YouTube for right now. But I know like must be stored securely. So I guess I could try to. I'm not sure how WebEx handles that, but for now I typically just do that. So I'll have it on YouTube and post the playlist on the yeah. Since I'm gonna post that on Discord the link, not officially on Canvas. That way it's kind of under the table like that. So yeah. And also, if I write any notes in class, I also post in a PDF form up onto Canvas as well. So in that Files tab, I'm going to have a folder called Notes, and then week 1, week 2, week 3, and so forth, and post a PDF of my notes up there as well. Copyright, I don't think there's much of an issue there. DRC, so yeah, I guess if you have any sort of disability, you need accommodations, of course, the DRC will contact me, and of course, I will, respond to the emails, and I'll just, handle the disability and, go through and, make accommodations based on that. So have a DRC contact me, and of course, I will do whatever I can to make the accommodations for you. Final exams, yeah, that's sort of I guess posted here, but I have the final exam linked already on this syllabus. But of course, you can check the final exam schedule using that link right there. And of course, to view any Canvas content, please use your ACE account to log in as yourself to check that out. That's what I think all this stuff really says right here. Incomplete grades. Okay, so for incomplete grades, typically the way this works is that, let's say after the drop date happens, and maybe something happens, you get sick or injury or something goes wrong that you can't continue, and also your grade in the class was pretty good, where it's believable that you would have failed because of that. If let's say you had a 0% in the class, then yeah, I don't think that would have made a difference whether you're going to fail either way, I think. But if you're doing well in the course, like doing decently enough where you have a chance to pass for sure, but the last few weeks you can't, do work because something really terrible happened, then a complete grade can be assigned to you. So what that really means is that you can sort of, for now you're good, and you have to finish up the remaining assignments and exams in the following semester. So you have until the end of the next semester. You can finish it earlier even, but you have until the end of next semester to finish all of your course content. So I don't want to really give incompletes out too much because it's sort of extra work for me. So it has to be something serious. So, for example, if let's say you had a breakup happen recently after a drop day, you can't continue a course. I mean, I can imagine breakups are terrible to deal with. I understand. We've all been there, but that's not really enough to get an incomplete. I don't think the university is going to really think of that as being an emergency enough. I know it's an emergency, I mean, it's easy for someone to say who's not going through it, but at the same time, you can't really have that be a reason for an incomplete. It has to be something more serious, unfortunately. So, um, and of course, if you don't finish, let's say you take an incomplete grade and you don't finish the material in time, you get an automatic F assigned to you. So you have to keep in contact with me, and we can somehow do the makeup assignments. Then I'll sort of do a grade change from incomplete to the letter grade you earned based on the remaining assignments you finished while doing the incomplete grade. Okay, library resources, that's right there. You can look that up. I'm not sure how helpful it will be. Maybe to find a book, I suppose, maybe library, but of course you can probably find it online as well. Missed classwork, usually it's a case-by-case basis. Now, of course, if you can't do some assignments or some exams because of religious holidays, let me know beforehand. And then, we can definitely make accommodations for that. But don't tell me a day of the exam because let's say um, a day or two before the exam, oh, can I take the exam early? It's like, well, I'm going to have the exam fully proofread or anything just yet because I wasn't expecting to have somebody ask for the exam early. So if for an early exam, for that reason, you have to tell me beforehand so I can, proofread the exam beforehand. So that way it's ready to go earlier than expected. So you have to let me know beforehand for that. So you can read through that, of course, as well. Rebel Mail. So of course, I mentioned you can use Discord or email to me. Now, if you do have to email me with something, it's fine, but please use your UNLV email. Don't use your personal email because this way, then it's all the communication is official. Because Discord is not an official communication medium, but it's okay for a quick question on something, right? But for more official contact, it's email. Use your UNLV email. So that way, it's sort of recorded on the server school servers with that. So that way it's all transparent, all the communication. So if I wasn't really accommodating well enough, you have proof that I wasn't because you tried to reach out to me, I didn't respond, or I gave you a really terrible response. Then you have proof that I was not really being responsive on something important. So that's kind of why. So it's more transparent, which is helps everybody in that sense. Um, Tutoring and coaching. I guess there's a link for that. I'm not sure how tutoring is done this semester, if it's in person or online still, but I guess the information should be here, located here as well. And they actually have, well, it says right here, second floor, A building and TBE, so I guess it's going to be in person, I suppose, this semester, so that's nice. Um, Writing Center, I don't think it's really going to apply too much to this course. Diversity statements, yeah, just treat everybody fairly. Don't be a jerk, basically. Just treat everybody fairly and respect each other. That's really all there is to that, which is a very fair, very simple to maintain that. I mean, I never had this issue really, but it's there. So there's that. And of course, the very last page has our schedule of topics for the semester. So of course, this can change. So there's certain topics I haven't really had a chance to look at in too much detail just yet. So I'd have to also kind of, brush up on it. But for the first few weeks, I'm definitely okay. But I think, let me see. Red black trees, I haven't really covered that on my own yet. So I know AVL trees well enough, so that for sure could be covered. But the MIT book really goes into a lot of detail with this content, red black trees, not much in AVL trees. So that's week 6 though, so I don't think it's a very hard data structure to learn. So I can probably pick that up sometime soon, and I can just be able to cover that. Um, I also have to cover this on my own as well. I kind of don't remember all the details of this algorithm. It's not really hard, but I have to like brush up on that. Everything else, for the most part, is actually kind of, in my sort of knowledge arsenal, if you will. Um, Although, I'm trying to, obviously, heap stored binary heaps, I may not, I may cover really quickly. Fibonacci heaps, I might just give an honorary mention. I might not really go into that in too much detail. Everything else here is kind of pretty much should be good to go. There's a couple of topics here and there I have to like, brush up on. So here on this last column of the syllabus, I had the red and blue. So the blue chapters are MIT book, and the red ones are from the UC Berkeley book. So I guess blue MIT is, I guess, in a colder area, it's northeast, whereas, Berkeley is nice, sunny California, so I guess it makes sense to have that, blue and red like that. So you can see here, there's several topics that have no red chapters because it's sort of not in the UC book. But for most part, though, a lot of content is in the UC book, but a few things though is not. So I guess these radix sort is not in there. B trees or black trees are not in there either. I think they have sort, they have merge sort, but not quick sort in the UC book, so it's kind of weird. So I'm not going to cover too much sorting in this class because you learn a lot about that in 302. But I'm going to go over a quick sort because I wanted to cover this selection problem, which is if you took my 302 class, I went over how for pivots for quick sort, you can find the median O of n time. Well, this is the algorithm that does that. So that's why I made code a quick sort because it's really kind of usable. It's really important for a quick sort to kind of guarantee that very nice runtime. So that's basically a rundown of the syllabus. So any questions right now on anything involving course content and whatnot? Well, I guess if you have a question, you can sort of type it as I'm doing this, but I guess I'll sort of talk a little bit more. So I guess for the first week, we'll be going over algorithms, and I guess it's cut off. It's supposed to be asymptotic complexity classes. It was supposed to be one line, but I guess I must have messed this up right there. But anyway, not a big issue though. So let's go ahead and talk about those content right now, since I have a little bit of time still. So I'll try to make it not so long of a day today, since it's the first day of this course, but let's go ahead and just talk a little bit about this. So, okay, so I guess, you've already been exposed to algorithms in 302. I'm not sure, how long ago it's been for you. Maybe some students might have taken 302 last semester, some might have taken it a few years ago. So let's do a little review of all this just in case. So, what is an algorithm? Well, it's basically, sort of a solution to the problem, but I think the definition is, that step by step process to solve a problem. Now, with an algorithm, basically, for most part, it has to be deterministic. So it doesn't really guess. It has a very structure. So step by step implies determinism, basically. And also, for all input, the correct output is always produced. Which, it makes sense. If it doesn't always work, well, it's not really an algorithm. It doesn't really solve this problem. So if you have a sorting algorithm that doesn't always sort the list, that means it doesn't really solve the problem sort this list, or not all the time, which is really kind of an issue. So that's that. And also, it must complete in finite time, which that's kind of a big obvious, top obvious bullet right there, because, well, if let's say it takes forever to finish, you can't really tell if it worked or not. So think of this in 302. Let's say, you have no sort of bound for how long the program should run for. So if you run the program and it's running for a very long time, how can you verify that it's right or wrong? It didn't stop. So you can't, it didn't stop and give you an answer that you can verify, okay, it worked, or okay, it didn't work. You don't have that. So if it runs forever, that you can't really verify if it's really valid. That's one of the later, maybe last week or so, we'll cover a little bit about. It's one of those undecidable problems in computer science and computational theory, where if it never stops running, how can you ever prove it'll stop running? If it's running still, how can you prove it'll stop at some point? There's no way you can prove that, which we'll talk about that, maybe a little bit at the end of the semester, depending on how far I get. So on a syllabus, I might take longer time to cover certain topics or short time to cover certain topics. So it's not really exactly week one will be this and week two will be that. That's sort of our schedule of topics. But I could even, of course, skip certain topics if it's not really important, if I'm a little behind and whatnot. But anyway, that's sort of like the basics of an algorithm. So then one thing is, how do we measure an algorithm? Well, the two main ones are, space and time. So space efficiency and time efficiency. Now we're going to focus mostly on time in this course because I don't have a really great knowledge in space complexity, although I do have decent amount, but I'm not really an expert on that. So time complexity. And of course, we use the growth rate of an algorithm. So amount of steps, I should probably say, amount of steps needed for the algorithm to finish. So, other words is the growth rate is what we use to measure. So of course, we could have an algorithm run on a computer that takes 5 seconds. Other one takes 10 seconds on a different computer. The problem is that all kinds of machines exist and different machines have different processing power. So really, we can't really use a computer's actual real runtime as a benchmark. Now, of course, the growth rate does have a sort of a relation to the runtime, but this growth rate is more universal. So for example, for linear search, it was O of n. It was O of n no matter what computer it's on. Now maybe if you have n steps, it might sort of run each step faster on a faster computer, absolutely, but it does not make the algorithm better. It just same algorithm, but is on a faster machine. So this growth rate is actually the best way to really universally measure the efficiency of an algorithm. So we also have a set of complexity classes. We have let me see, we have big O notations. I'll just kind of just list it out like this. We have sort of big O, which you learned this in 302. Big omega, I'll use a symbol, big omega, and then big theta. So big O represented upper bound. So we'll go over upper bound in a second. Omega is lower bound. And then theta, I guess we'll say exact bound is probably the right word to use here. So upper bound, what does upper bound really even mean? Well, it means that, so So basically, in the worst case, the amount of steps does not exceed the bound, if you will. So it's the worst case scenario. It will never go beyond this amount. So for example, if linear search is O of n, it means in the worst case, it will never get worse than O of n. Now, of course, we'll talk about this a little bit again. It's a recap this from 302. But for example, if I said that if I said that linear search is O of n squared, if I said that statement, I would be technically correct because, well, it can't get worse than O of n squared, right? Because if it can't get worse than O of n, it can't get worse than O of n squared. But it's a very bad statement to, say. But of course, that wouldn't be invalid to say that. But we'll do some examples in a bit on this. Then big omega is really in the worst case, the amount of steps is not below the bound. I just read to write this. So really means, this means really at most is the best way to describe this. And omega is going to be at least. So in the worst case, if it's omega, in the worst case, it has to at least be this many steps. That's what omega is. In big O, in the worst case, it can't be more this many steps. So typically, we try to always lower the upper bound as best as possible. We always try to increase the lower bound as best as possible. That still sets that bar within the runtime of the algorithm. So omega is at least, big O is at most. And an exact bound, well, I guess that's really, okay, I'll just put this here. It's theta is really at most and at least at the same time. So in the worst case, the amount of steps does not exceed or is not below the bound, whatever bound we set for the algorithm. So the bound will be some type of a function of some sort. So that's kind of like a quick sort of, recap on what these were. So I'm not going to really, go ahead and define all of these, like in terms of their mathematical definitions. I think from 302 you remember what those were. But for example, let's do a couple of, let's talk about this a little bit right now. So really we have a set of asymptotic complexity classes. So we have O of 1, which really means constant. So I use 1 because 1's that simplest constant you can think of. Sometimes O of C is also used for this as well. Then we have O of log n. Then we have, I'm going to list all of them out. Maybe I'll put some more here in a second, but I'll just put a couple of more common ones. Then we have O of n. Then we have O of n log n, which means n times log n. O of n squared. And then, we'll have something O of 2 to the power n or so. So each of these is going to be an asymptotic complexity class. So these are going to be, these are just a few asymptotic complexity classes. So I'll put this here just. So these are kind of ways we can group functions into an asymptotic class. So for example, O of n contains all linear functions. So they're all asymptotically in that same class. So 5n, 10n, n over 50, whatever, all of those are in an asymptotic linear sort of growth rate or class. O of log n, same idea. It has all logarithmic functions. Now, I'll talk about this in a second here, but one question is, for O of log n, what's the base of that log? Well, I'll explain that in a little bit, but just to think about what's the base of the log there. Anyway, for now, we'll just pick a base, but O of n, all of these functions in O of n they have a bigger growth rate than everything is log of n, which means that it's a slower algorithm. So for example, if you have an O of n squared algorithm like bubble sort, and you have merge sort O of n log n, that means merge sort is faster. It takes fewer number of steps to complete its task. So n will always be the size of the input, and we have a function that sort of tells us the growth rate based with respect to the input size. So we can see as n gets larger, then O of n squared time, like bubble sort, will grow much faster. So it has a much more steps it takes to run, and log n is much better. So the smaller growth rate, that means is a faster algorithm. And of course, for big O notation, which is really bizarre, so for O of n, actually, I'll just try O of n squared, actually, just to make a big example. O of n squared contains all quadratic growth rate functions, but also it contains all the n log n functions. It contains all the linear functions. It contains all the O of log n functions also. Technically, that's true because if the bar is set at O of n squared, then anything that's at O of n squared runtime or lower is going to be in that set. However, it's a very bad question to ask. It's almost like saying, if let's say you're asking, is linear search O of n squared? It's almost like asking, are you shorter than 1 mile? And it's like, well, I think you are. So that's not very helpful. It doesn't really tell you how short or tall you are. So you want to, of course, always lower the upper bound as best as possible to get a very accurate answer. Lower bound is the opposite. You want to increase it as best as possible. That still works, but have to make sure it still kind of bounds the algorithm. So for example, so for linear search, the worst case is O of n. But if you try to say O of log n for linear search, now you're wrong, because it can get worse than log of n. It can get at most n. So it means if you say linear search is O of log n, that's actually, not only is it a bad statement, it's actually a wrong statement. If I say, is linear search O of n log n, that is technically correct, but it's not a good statement to say. So you want to make sure that the upper bound is lower as possible, but still bounds the runtime of the algorithm. So we typically consider big O for most part because big O encapsulates every possibility. So for example, linear search sometimes could be better than O of n, right? But O of n is like, it won't get worse than this. So we always typically consider big O over omega and theta. But for certain problems, we consider omega in certain instances. But yeah, that's about that. So next question is, what is the base of the logarithms essentially for O of log n? So let's say, for example, I want to say, is log base 2 of n, is it in the set O of log n? And I should have brushed up on logs before this class began, but oh well, I think I kind of remember this pretty well. So remember, for big O notation, how do we show this in the set O of log n? Well, it's a very simple formula we use, right? So we have to say, basically, log 2 of n less than or equal to c times log, I'm going to pick maybe a base b of n, where n has to be larger than some initial n naught value, and c is some constant bigger than 0. Okay, so I'm going to convert. So remember, there's a formula you can use for logarithms, which I hope I remember this correctly, that can convert from one log to another. So I'm going to basically pick a different, I'm going to convert this log base 2 of n into log base b of n. So whatever b is, we don't know, we just picked something. So I believe it goes like this. Log b of n over log b of 2. I hope that's the right formula. I can't remember this perfectly, but I think that's the right formula, I think. So then c times log b of n. So basically, as long as, I guess I'll say as long as n naught is larger than 0, I'll say larger than 1. Like larger than 1. As long as c is larger or equal to log b of 2, this works. That means log 2 is in this. So basically, the idea really is that no matter what I choose, if I would have chosen log 3, log 4, any of them, I could easily convert them like this. Which means that between any two logs, log A or log B, any two logs you can pick, they're off by a constant factor, all of them. Which means that O of log n contains every logarithmic function you can think of. So log 10, natural log, log of 2, any of them, they're going to be in the set O of log n. So they're all asymptotically in the same, they have the same asymptotic growth rate. They're all logarithmic. So I chose 2, but I could have chose log of A, same idea. Because log b of A, if I had chosen A instead, A is a constant, B is a constant, log b of A is also a constant, so this C value is not growing as n gets larger. So that works. So every log function is an O of log n. So we have this definition of big O and big omega and big theta. So this is the definition of big O. Now for omega, it's the same thing, except you have to flip the inequality. And then for theta, so in order for a function to be in theta, it has to be big O and big omega, both. So if f of n equals theta g of n, f of n must be O of g of n, and f of n must be omega g of n in order for it to be theta of n. And O and theta are simple to show using this mathematical formula. Now, there are times where there's a nicer, more mechanical way to actually do these to show if two functions belong in the same class or not. So we also have another sort of method called L'Hopital's rule, which is you might have learned this either in 302 or maybe in a math class. But L'Hopital's rule is just a way to sort of nice mechanical way of being able to show which function has a bigger, smaller, equal growth rate. So given two functions, f of n and g of n, and we're going to bring up, calculus. Now, I know my 302 class this would scare students, but you're in 477, so you've already been through every single terrible experience in life and everything. So you're definitely, this doesn't scare you anymore. 302 students, this will scare them, but you guys are definitely, you're basically been through a lot, so you can definitely handle that. So we have these two functions, f of n and g of n, and we want to see which one is bigger growth rate, smaller growth rate, or whatnot. So we set these two functions to infinity, and then we want to see what's the ratio. So there's three possible scenarios. So we can have infinity could be the result. It can diverge to infinity. It can converge to 0 or to some constant larger than 0. So infinity means that f of n has a larger asymptotic growth rate. If it's 0, then g of n has a larger asymptotic growth rate. So asymptotically means that it's not in the same complexity class, really. That's what it really means. And if it's a constant, then f of n and g of n have the same asymptotic growth rate. So basically, if it's a constant, that means f of n and g of n are both linear growth rates, or they're both quadratic, or they're both logarithmic, whatever. That's what it means. But if it's infinity or 0, then one grows much more than the other, basically, is what this does. So this can be helpful in certain situations to help you basically determine which function is bigger or smaller. Let's do a few examples of L'Hopital's rule. So L'Hopital's rule. Okay, so in this case, we're going to have, let's try the following. going to have maybe n squared minus 30n plus 1000 over, let's say I'll try 50,000 n plus 24,000, like that. So we want to see which one has the bigger growth rate. So, okay, from calculus, right, we just set n to infinity. So infinity over infinity equals 1, right? That's all it takes. And then we get 1, so obviously they have the same growth rate. And I guess the answer for this is wrong because obviously calculus can't be that simple. And at the same time, we can see that, well, this function up top is quadratic, one below is linear. So obviously, no linear function can really ever pass quadratic. So now in this situation right here, for a very big n and a very big constant to use for linear function, it'll have a very big head start over this quadratic function. Actually, I'll make it minus 1,000 even, minus 1,000, sorry. So we have a big head start for a linear function below. However, the function up top will pass it. So as n gets larger, sooner or later, this quadratic function will pass that linear function below. It's like that tortoise and the hare story. So the hare has a very big head start, and tortoise eventually catches up and beats the hare. It's kind of like that. So we want to sort of show, using this L'Hopital's rule, that the function up top does in fact grow at a larger rate. So let's go ahead and try that. So I'm going to go ahead and factor the n's out. So I'm going to go ahead and say n. So it'll be just n over here minus 30 minus 1,000 over n. Then we have n 50,000 plus 24, which is a really big constant, so it's 4 zeros, over n, like that. So you factor the n's out, pretty simple. Then we can sort of cross these off. And now we're left with n minus 30 minus 1,000 over n over this amount. So in this case, you set n to infinity. Well, these will be definitely 0. Anything over infinity becomes 0. So we're left with n over some constant. As n goes to infinity, this will definitely become infinity. Yes, so yeah, I was going to talk about that as well, but derivatives, you can also do that as well for some of these. So this one we didn't have to because it's pretty simple of an example, but for more complicated examples, it would be very nice to take a derivative of the first. You have two functions, f of n, g of n here. Take derivative of the two functions and put them back together, and then see which one is larger or equal and whatnot. So that's another way we can do it as well. So in this case, we don't really need to because we could just do a little bit of algebra and figure this out. But for example, if we have something like this, let's say I want to show if this is actually correct. I want to see if this is actually true or false. Now, using the standard method like this, so from 302, which let's say the method like this, we have, let's say, square root of n less than or equal to c times log a of n. I can't really think of a constant or an initial n value to make this work. So in this case, L'Hopital's rule can be very handy. So right now, okay, I want to show which one has a bigger growth rate. So let's say I want to know if equal growth rate, this is correct. If the log function has a bigger growth rate than square root of n, it's also correct. But the only issue is if root n is bigger than O of log n, then this is actually not valid. Let's go ahead and try L'Hopital's rule on this example and see what happens. The limit as n goes to infinity, I'll just put root of n over, and I'm going to pick a log function. Let's try natural log. And the reason why is because in calculus, there's so much work done on natural logs. And as I showed earlier, it doesn't matter what the base of the log is. So log of e, or natural log, and log of 2, they're asymptotically the same. So when you have a logarithmic sort of function being used, you can just pick a champion to represent the log function. So typically, natural log is a good champion to choose because really that one is good enough. It handles all the logarithmic cases, and there's so much work done on natural log. So in this case, well, same idea. It's really hard to just, okay, what does it converge to? It's really not clear because you can't do infinity over infinity in calculus. That's not going to give us a clear answer. So in this case, what we can do is take a derivative of this top function f of n and g of n separately and put them back together, because we don't really care about the exact value. We care about that ratio. So for these functions that are so for algorithms, typically all the functions they're sort of always growing. So taking a derivative of a growing function does kind of bring it down one level. If you bring both functions down by one level, that ratio is still maintained. So I'm going to go ahead and take a derivative of this function. So let me see, n up to the 1/2 is 1/2, and up to negative 1/2. So I guess it's going to be basically just 1/2 root n, I believe, is the solution there. And natural log derivative is, I believe, 1/n. So from algebra, we do a multiply by the reciprocal. So we have n/2 root n. We can factor the n's out to get root n/2. And now we have a concrete answer. This is going to definitely go to infinity, because if we set this to infinity, square root of n/2 will grow to infinity, which means that root n has a bigger growth rate than natural log of n. Or in other words, root n has a bigger growth rate than any logarithmic function. So there's no way, so logarithmic functions, all of them have a smaller growth rate than root of n. So that means that this statement here is not valid, because O of log n cannot bound any root n function. So basically, so that's kind of a quick sort of introduction to algorithms from CS 302. So really just, for the most part, we focus on big O notation because big O is more, it's not super exact, so you can kind of cover all the possible cases. So, because there are certain algorithms out there where in the worst case, it's O of n, but in the best case, it could be, let's say for like insertion sort, for example, it's O of n squared in the worst case, but it can be O of n in several different cases. But we still want to consider that the worst case is really, we always want to, think about what's the worst case scenario. That sort of gives us the complete spectrum of this algorithm. So you want to always have the worst case scenario, which sort of gives us everything. So we consider big O typically, and we always have the worst case scenario as the runtime, because that sort of encapsulates all the cases. And typically, the worst case and the average case are almost usually the same. Now, average really means that most of the time, or usually. So insertion sort, for example, is worst case O of n squared, but on average, it's also going to be some quadratic runtime, but it has some cases where it can be better than quadratic as well. So then you might say, well, isn't it better than O of n squared? Well, yeah, for that one input case. But overall, in the worst case and most cases, O of n squared. So big O is kind of more preferred way to sort of set up these asymptotic, or sort of to group these algorithms, using big O for the most part. So I'll have a homework assignment posted up sometime before Thursday. Now that'll be our first homework. It'll be just like a 302 review, so just grouping functions and listing them out and doing this big O L'Hopital's rule and stuff. So a little review, a little refresher from 302. But I guess it's sort of a first day, syllabus day, so I don't have to go too extreme right now. So I end class a little earlier today. So I guess for now, just sort of take care, stay safe. Thanks for watching, and I will see you guys on Thursday.